We're about to dive into the world of one of our planet's most dangerous superbugs. But this isn't your typical story of a pathogen versus medicine. Oh no. This is a story about a conspiracy, a secret partnership hidden deep inside the enemy's own DNA. The bug we're talking about is Klebsiella pneumoniae. Now, this is a notorious bacterium, a leading cause of really serious, life-threatening infections in hospitals all over the world. It's tough, it's incredibly adaptable, and it's getting scarily good at shrugging off our best antibiotics. But this is where the story gets really weird. Scientists have found something lurking inside the superbug, something that, by all accounts, should be its mortal enemy. But instead, it seems to be its most powerful ally. So what if the secret to this superbug's strength is actually a saboteur working from the inside? All right, so let's officially kick off our investigation. First things first, we need to properly identify our suspect and really get a handle on the scale of the threat we're dealing with. So, Klebsiella pneumoniae isn't just any old bacteria. It's a card-carrying member of the infamous escape pathogens. You can think of this as a most wanted list for bacteria. These are the ones that are masters at escaping our antibiotics, which is exactly what makes them so dangerous. And that leads us to the central mystery here. Klebsiella's ability to pick up resistance and evolve isn't just impressive, it's alarmingly fast. So where does it get this incredible power? Well, as it turns out, the answer is hiding in plain sight. To find the source of this superbug's power, we have to look deep inside its genetic code. And what we find there is, well, it's kind of spooky. We find the ghostly leftovers of ancient viral invasions. These ghosts are called prophages. Okay, so what is that? A prophage is basically the DNA of a virus, in this case a virus that infects bacteria, that has managed to sneak inside and stitch itself directly into the bacterium's own chromosome. It's essentially a virus in hiding, just lying dormant right inside its enemy's headquarters. Now, you might think, okay, so maybe there's one or two of these viral ghosts hanging around. But get this, researchers have found that a single Klebsiella bacterium can host up to 16 different prophages. That's a huge number. It actually puts it in the top 5% of the most virus-packed bacteria in the entire world. And we're not just talking about old, broken fragments of viruses. As you can see right here, over half of the prophages they find are classified as intact. That means they appear to be complete, functional viruses, armed and ready to wake up and get to work at a moment's notice. So we have a bacterium that is absolutely stuffed with sleeping viruses. Logically, you'd think its number one priority would be to lock down and keep any more viruses from getting in, right? Well, this brings us to the biggest twist in this entire investigation, a paradox that turns everything we thought we knew completely on its head. You see, Klebsiella has this thick, slimy outer layer called a capsule. For decades, everyone just assumed this capsule was a shield, armor to protect it from threats like viruses. But the shocking truth is the exact opposite. The capsule isn't the shield. It's the key. The very thing that's supposed to protect the bacterium is what these viruses use as a docking station to break in. Just how important is this key? Well, a phage, that's the virus, is 9 times more likely to successfully infect a Klebsiella bacterium if it recognizes its specific capsule type. If it doesn't have the right key for the lock, the virus just can't get in. And hey, this isn't just a wild theory. As a study in the ISME journal puts it, the capsule seems required for infection. In their experiments, when the scientists actually removed the bacterium's capsule, the phage couldn't infect it anymore. The shield was, in fact, the door. So this completely bizarre relationship, where a bacterium's shield is also a viral key, it's not a mistake. It's actually a very sophisticated evolutionary dance that ends up making the bacterium even stronger. They aren't just enemies, they're partners. Here's how it works. It's a 3-step process. First, a phage attacks using a specific capsule as its key. Second, this creates intense pressure, so any bacteria that happen to change their capsule are the ones that survive. And third, all this viral pressure forces the whole bacterial population to constantly evolve its disguise. It's a process called serotype switching. The phage basically acts like a personal trainer, forcing the bacteria to become more diverse and adaptable. So the viruses are making the bacteria evolve faster. But how does this connect back to our original problem, antibiotic resistance? Well, this is where the conspiracy turns into a full-blown criminal enterprise. The phages aren't just partners, they're smugglers. To understand this, we need to know about two different types of antibiotic resistance genes. First, you have the core ARGs. These are the bacteria's innate defenses. Pretty much every Klebsiella has them. But the real danger? That comes from acquired ARGs. These are the heavy-duty weapons that get smuggled in from other bacteria, and they are what create the most dangerous superbugs. Now, when it comes to this acquired resistance, there's one specific family of Klebsiella that is the undisputed kingpin. It's a group known as CG258, and this particular family has become the most successful, most outbreak-causing version of the superbug all across the globe. If there's a smuggling operation happening, this is its headquarters. And what do you think we find when we look inside CG258? This chart is incredibly telling. The dangerous CG258 strains are absolutely packed, with an average of 8.1 prophages. Now, compare that to a less notorious relative like CG23, which only has about 1.8. The most dangerous strains are also the most virus-infested. That cannot be a coincidence. And here it is, the smoking gun. In those notorious CG258 strains, where do we find those dangerous smuggled resistance genes? This chart shows that a staggering 60% of them are located inside the prophages. The viruses aren't just carrying messages, they are the getaway cars, smuggling the tools for antibiotic resistance directly into the superbug's genome. So the secret ally is exposed. The ghost in the genome is the smuggler. And all of this leads to a final, absolutely fascinating question. If these viruses are so good at breaking into bacteria and editing their DNA, could we turn the tables? Could we engineer these phages to become assassins, to tear down the superbug from the inside? The investigation is over, but a whole new chapter in our fight against superbugs may just be beginning.